Hi dear students, welcome you all to the Brilliant Group of Institution. In this session, we are going to discuss the most important MCQ for the CBSE Grade XII Chemistry from the first organic chapter, that is Haloalkanes and Haloarenes. Okay, so here we can begin from the first question from the chapter Haloalkanes and Haloarenes. Okay, here we have the first question. Hydrocarbons having double the number of carbon atoms than present in the original alkyl halide are produced by using which of the following reaction? So hydrocarbons, it's a preparation of hydrocarbons having double the number of carbon atom than present in the original alkyl halide. Let me take one alkyl halide, for example, methyl chloride. Alright. So in methyl chloride, let me take two molecules of methyl chloride. So let me write CH3Cl, one more methyl chloride. How we can double the number of carbon atom? Here you can see one carbon in one haloalkane, another carbon in another haloalkane. So how we can combine them? So very simple. Let's treat it with which one? 2 sodium metal, right? What is this reaction in presence of dry ether? So this 2 sodium can remove this 2 chlorine as 2 NaCl. So what you will get it? This CH3 and CH3 will combine together. We will get ethane as a molecule. So there is a double in number of carbon in the hydrocarbon. Right. So hydrocarbon having double the number of carbon atom when compared to their present haloalkane is said to be which reaction? Wurtz reaction, right? Wurtz reaction, option D is correct. You know Sandmeyer's reaction we are using to convert which one? That is a preparation of diazonium chloride. We are converting into chlorobenzene, bromobenzene, right there. And Fittig reaction, you know, it's a conversion of chlorobenzene or bromobenzene haloarene into diphenyl or biphenyl. That is called Fittig reaction. Williamson synthesis, you know, it is a preparation of ethers, right? So the first question, option is D. Let's go to question number 2. Which one of the following the correct increasing order of boiling point of the following compound? What are the compound given? 1 bromoethane. I'm not writing the detailed structure. Okay, first compound is 1 bromoethane. So there are 2 carbon with a bromine, 1 bromoethane. Second one, 1 bromopropane. So there are 3 carbon atom with a bromine. And the third compound is 1 bromobutane. So there are 4 carbon atom total with a bromine. And the fourth compound is bromobenzene, a haloarene. Alright. So this is the compound that we have. See, boiling point. The question is related to boiling point. You know, boiling point mainly depends on different factors like molecular mass. As the mass of the carbon number or mass of the molecular mass of the compound, if it is very greater, its density greater, so the boiling point greater. So the major factor affecting boiling point is mass. The second factor, branching. As the number of branching increases, boiling point decreases. You know, branching number increases, the surface area decreases, boiling point decreases. Okay, let's go. Which of the following molecule having a greater number of mass? Definitely D option, right? Because they contain 6 carbon atom. Alright, and there are 5 hydrogen atom with a bromine. Greater mass is there. Alright, so fourth one having greater boiling point. Okay, then next one, when you consider, we can discuss about third compound. The third compound, you can see that bromine. All of them contain bromine as the halogen, but the third compound contains 4 carbon atom and all are in the linear chain, surface area very greater, no branching. So third one. After that, we can go to second one because it contains 3 carbon and 1 bromine, second one, and then first one. So what is the major factor affecting boiling point? First one is mass. Greater the molecular mass, greater boiling point. Second reason, as the branching comes, boiling point decreases. Alright. So here, I think given in the correct option, bromobenzene. one bromobutane, one bromopropane, one bromoethane. Which is your answer, dear student? That's option A, right? Option A can be the correct answer. Okay, let's go to question number 3. In question number 3, we have name the following aryl halide as per the IUPAC system. Nomenclature question we can expect, okay? Haloalkane. So here you have a benzene ring and there is a chlorine and there is a alkyl chain. What is actually the alkyl chain present? What is the common name of the big alkyl chain on the benzene ring? That is what? Isobutyl. But we cannot use isobutyl. That's a common name, okay? Let's go. Here we have alkyl chain is there, chlorine is there on the benzene ring. So chlorine we have to give highest priority. So number 1, number 2, number 3, number 4. Okay. So first position what you have, chlorine is present. So 1 chloro. 1 chloro starting with option A and C. So let me cut option B and D. That's option D also possible. 1 chloro is there. Okay, let us check it. Then how to name the big branch? So let me start. Chlorine is the, alphabetical order. Chlorine is coming first here. So therefore 1 chloro, 4th position, dear student. On 4th position of benzene ring, what you have? On the 4th position, how to name isobutyl, the big chain? Dear student, how to name a big chain like isobutyl? Very simple. Which carbon directly connected to benzene ring? Which in the branch, which carbon directly connected to benzene ring considered as number 1? So this is number 1. After that, select a longest chain in the branch. In the big branch, select a longest chain. Either you can take 1, 2, 3 right or 1, 2, 3 the above. Above one. All are correct. All are fine. Now let us name the big branch. Okay, I am going to write the name of the branch in a bracket. Second position you have a methyl group. Therefore 2-methyl. Alright. 2-methyl over. What is the remaining chain? There are 3 carbon, right? There are 3 carbon in the chain. So 1, 2, 3. And it is not propane. It is a branch, right? Therefore propyl. What is that? Propyl. So 1 chloro, 4th position, 2-methyl propyl and word. Which is the parent chain here? The on benzene. Right? On benzene. So any answer is matching with this one. 1 chloro, 4, 2-methyl propyl benzene. Of course, your answer is option C is the correct answer. Alright. So let's go to question number 4. Isomers of the compound C4H9Br. You know what is the compound C4H9Br? It is a haloalkane. Because there are around the hydrogen number and carbon number almost are double. Then bromine is there. So it's a haloalkane. Let me write the possible structures. Okay. First structure. 1, 2, 3, 4. So total 4 carbons are there with a bromine. It can be one of the structure. You can fill hydrogen, okay, CH3, CH2, 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 one compound. Second compound, I can make the position of bromine into second carbon. This is 1 bromobutane. Let me place it, CH3, CH2, CHBr and CH3. What is this name of this compound? 2-bromopropane. Sorry, butane. And option C or compound number C, what we can write, dear student? So bromine position over. Now let us interchange the alkyl group. Okay, 1, 2, 3. Okay, 1 CH3 as a branch and 1 bromine here. So this is possible, right? Alright. This is one another structure. And 4th structure is possible or not? Possible. You can place the bromine on this carbon atom. So you will get CH3C, CH3, bromine, CH3C. All are different groups of the same molecular formula C4H9Br with different structures. Alright, so let's go to the option. What is the first compound? 1 bromobutane. What is the second compound? 2 bromobutane. What is the other compound? 1 bromo, 2-methyl propane. What is the fourth one? 2 bromo, 2-methyl propane. So I think all the 4 compounds, right? Total 4 compounds are there. That is only given in option C. 1 bromo, 2 bromo, 1 bromo, 2 methyl, 2 bromo, 2 methyl. Yeah, all the answers are coming under option C. Okay, let's go to question number next one. Very simple question. Which reagent will use for the following conversion? What is the reaction, dear student? Very simple. You know, it is a pure hydrocarbon, right? It is a pure hydrocarbon. It's a pure hydrocarbon. What is that? Butane. Butane converted to what? 1 chlorobutane, 2 chlorobutane. How the addition of chlorine to a hydrocarbon is called? A hydrocarbon reacting with the chlorine in presence of light or heat. That is called substitution reaction, right? Substitution reaction. So, if you want to add chlorine into a haloalkane, especially alkanes, the best reagent is which one? Addition of chlorine in presence of light or heat. So, what is the answer? Option D. Okay, chlorine in presence of UV light or heat is also fine for making a substitution reaction. Okay, next one. A hydrocarbon, it's a pure NCERT based question. It's an NCERT question. A hydrocarbon C5H10 does not react with the chlorine in dark. Does not react with the chlorine in dark, but it gives a single monochloro compound C5H9Cl in bright sunlight, which means it can undergo substitution reaction in presence of sunlight. Yes or no? So it should be a alkane. It should be a hydrocarbon alkane. What are the possible structures of C5H10, dear student? C5H10 can be a alkene. It is a formula of which one? CnH2n, right? Yeah, it is an alkene formula. What is the alkene? Pentene. 5 carbon containing alkene is which one? Pentene. Alright. It can be pentene as one of the structure. What is the other chance with the same formula? It can be cyclopentane. It can be cyclopentane, dear all. What is cyclopentane? This one. You know, each carbon contains 2 hydrogen atoms. Right? Each carbon contains 2 hydrogen atoms. Now you observe there are total 5 carbon atoms and 10 hydrogen atoms. So C5H10. So either this compound C5H10 can be pentene or it can be cyclopentane. Now the question, which one can be selected for this option? What is the correct answer? Cyclopentane, because alkene, this is an alkene. Generally, alkanes are undergoing substitution reaction in presence of sunlight. But this is an alkane, right? Cyclopentane, it is a pure alkane. It's a cyclic, that's it. So no problem. So let's make chlorination. You add Cl2 in presence of light, H nu. What will happen? One of the chlorine, substitution. What is meant by substitution? One of the hydrogen is leaving, one of the chlorine is substituting. We will get the compound chlorocyclopentane. Chlorocyclopentane. This is what happened. So the question, the hydrocarbon is, which is your hydrocarbon? That is cyclopentane. Option D is correct. Pentene, alkene cannot undergo. Pentyne, alkyne cannot undergo. Pentane not matching with the formula C5H10. Alright, so only the possible alkane is cyclopentane. Alright, let's go to next question. Benzylic halide contain. You may study so many different type of compound in this chapter. Vinyl group, allylic group, benzylic group, phenyl group, etc. What is meant by a benzylic halide here or benzylic group? Sorry, benzylic group means we can draw like this. Okay, this is a benzene ring. Okay, this is a benzene ring. Benzene ring, if it connected to a carbon, then it is called benzyl group. So for example, we can write, okay, this is a benzyl group. Benzene connected carbon CH2. Now it is called a benzyl group. Or you can say from toluene. They are derived from toluene. You know, toluene means benzene with the CH3. If the CH3 lose one hydrogen, yeah, it becomes a benzyl group. Benzyl halide. So can I please say one halide? Okay, chlorine. Alright, fine. So they are asking you the question in terms of hybridization. Okay, Here this is the halogen. What is the hybridization of this carbon? You know, the carbon atom is completely single bonded. You know, single bond connected carbons are sp3 hybridized, double bond carbons are sp2 hybridized, triple bond carbons are sp hybridized. Correct? So you see this compound, the chlorine connected carbon is having a single bond only, therefore it is sp3. Okay, sp3, and it is connected to a benzene, phenyl. Okay, let's see. Benzylic halide contain sp3 hybridized. What is option A? sp3 hybridized carbon atom next to an aromatic ring bonded to a halogen. Yes or no? Halogen connected carbon is sp3 to which an aromatic ring is connected. sp2 possible? No, not sp2. And option C, sp3 hybridized carbon atom next to carbon-carbon double bond. Right? Option A is the correct one, right? sp3 hybridized carbon atom next to an aromatic ring bonded to a halogen. Correct? So option A is the correct one. Next question. Which of the following compound has the highest boiling point? Again, boiling point question. Option A is which one, dear student? Chloropropane. Option B, chlorobutane. Option C, terbutyl chloride. Option D, that's 1-chloro, 2-methyl, 1-chloro, 2-methyl propane. You see, which one having greatest mass? Option B, option C, option D having equal mass. You can see the number of carbon similar, hydrogen similar, halogen also similar. So among isomer, how we can find out which one having greater mass? Those compound having greater surface area. Right? Option B having greater, dear student. Option B having greater. Why? Option B, all carbons are in a straight chain, surface area very greater, therefore boiling point also greater. Coming to after option B, which one we can suggest? Option D. Option D contain only the CH3 as a branch, only one branch. So option D. But option C, all of you look at option C. What is this compound? What is this compound? Terbutyl chloride. Terbutyl chloride. This is the compound. Here you can see more branches are there. So option C lesser. Then lesser number of carbon atom is present in option A. So this is the correct order. Question is which one having highest boiling point? Let's go with option B. Okay. Let's go to next question. Identify a very simple question. Identify the compound Y. Where is Y? Where is Y? Where is Y? Y is here. Identify the compound Y in the following reaction. Dear student, what is your starting material? Aniline. Your starting material is which one? Aniline. Aniline treated with Na, NO2 and HCl under 0 to 5 degrees Celsius. What it is called? Diazotization reaction. What you will get? Benzene, diazonium chloride. Benzene, diazonium chloride. Benzene, diazonium chloride having so much application. You studied Sandmeyer reaction, Gattermann reaction, Haloalkanes reaction, yes or no? So this benzene diazonium chloride, when you treat it with the copper chloride, what is happening? CuCl or Cu2Cl2, what will happen? You will get chlorobenzene, right? You will get the material as chlorobenzene with the nitrogen. What is the name of this reaction? Come on, what is the name of the reaction? Sandmeyer's reaction, yes or no? So what is your answer? Option A, chlorobenzene is the product. Very simple question. Shall we go to the next question? Okay. Para-dichlorobenzene. What is para-dichlorobenzene? This one, right? Para-dichlorobenzene has dash and dash than those of the ortho and the meta isomer. What is ortho isomer? Dichloro means chlorine, chlorine nearby. Ortho. Which is meta? Meta means like this. Alright, this is ortho. This is the one ortho. This is meta dichloro. This is para dichlorobenzene. Okay. All of you keep in mind, mostly they will ask you the boiling point or the melting point question. All of you keep in mind, melting point order of these three species are POM. What the name? POM. P-O-M. This is the order. Keep in mind. The melting point of these systems are POM. Para greater, then ortho, then meta. And if they are asking you boiling point, just interchange the first two systems. Ortho, para, meta. That's it. So melting point order of para, ortho, meta, dichlorobenzene in the order POM. P greater, O greater, M. And the boiling point mean ortho and para, just interchange. That's it. Okay. So your answer is ready now. Let's go to the answer. Para dichlorobenzene has dash and dash than those of ortho and meta isomer. What we can say, para dichlorobenzene having higher melting point. Yes, para higher melting point is there. Higher melting point is there. Higher melting point is in option A and option D. So let me cut option B and C. Then what about their solubility? You know, dear student, para products. You know, para products having high symmetry. No, you may study it right. Para products having high symmetry because of greater symmetry. That's why it possesses greater melting point. You know, because of the greater symmetry of para dichlorobenzene or para product, they occupy in the crystal lattice very tightly. Because of greater symmetry, they can occupy in the crystal lattice very tightly. They are having rigid structure. Therefore, they are having high melting point. So, rigid one molecule mean they are easily soluble or less soluble in water. They are less soluble. Whatever the solution or whatever the solvent, their solubility decreases because they are little rigid, stiff material. Okay, so your answer is which one? Option A, higher melting point and lower solubility compared to ortho and meta isomer. Okay, keep in mind this order. Go to the next question. Decomposition of benzene diazonium chloride. Already we discussed this question. Decomposition of benzene diazonium chloride. This is benzene diazonium chloride by using Cu2Cl2. Cu2Cl2 in presence of HCl is known as, what you will get, dear student? Chlorobenzene. What is the name of this reaction? Is called Sandmeyer's reaction. What? Sandmeyer's reaction. Option C. You studied one more reaction. Sandmeyer, one more halogen, you can add it, right? This is chlorine. What is the other halogen? Yes, bromine. Bromine. How you want to add? Cu2Br2 in presence of HBr. Then you will get bromobenzene. You can add only chlorine and bromine on benzene ring by using Sandmeyer's reaction. What about Gattermann reaction? What is the difference between Sandmeyer and Gattermann? Gattermann means instead of Cu2Cl2 or cuprous chloride, what we are using? Copper powder, right? Copper powder. That's it. You know what is Wurtz-Fittig reaction, Friedel-Crafts reaction, Finkelstein reaction? Sandmeyer's reaction is the correct answer. Next one. A primary alkyl halide would prefer to undergo. Easy, come on. A primary haloalkane would prefer to undergo which reaction, dear student? We studied major SN1 and SN2 reaction. SN1 mechanism, what is the reactivity order? Tertiary greater than, secondary greater than, primary. What about SN2 mechanism? Primary greater than, secondary greater than, tertiary. You know the reason, everything. Why SN1 mechanism, tertiary greater? SN1 mechanism, it happened through two steps. In the first step, formation of carbocation. What is the stability of carbocation? Tertiary greater than, secondary greater than, primary. Therefore, why in SN2? Primary greater. SN2 mechanism favor less steric hindered haloalkane. In tertiary mean so many bulky group. Primary less bulky group. Steric hindrance is very less. Attack is very easy for the nucleophile. So SN2 mechanism favor in primary haloalkane. Answer is option A. Primary haloalkane prefer to undergo SN2 mechanism. Tertiary haloalkane prefer to undergo SN1 mechanism. Okay, keep in mind. Next one. The position of bromine in the following compound can be classified as. What is the position of bromine in this compound? Simple. Let's go. What is the compound given? CH3, CH, double bond, CH, C, Br, and then we have CH3, CH3. Yes, student, this is the compound given. Okay. Which position is this? Let me revise all three topics, the major topic in this compound, in this chapter. A, B, C. Vinyl, allyl, benzyl. What is vinyl group? Vinyl group means CH2 double bond, CH single bond. It's called vinyl. With a halogen, for example, you consider chlorine. So this is called vinyl chloride. And what is meant by allyl group? You write once again vinyl group, CH2 double bond, CH single bond, put one more carbon, it becomes allyl. So CH2 with the chlorine. Now it is allyl group. Benzyl, I already told you. What is benzyl? A benzene with one carbon is called benzyl group. How we can identify if the exact group is not given? You please don't expect vinyl, allyl, benzyl as the same compound. You can check it through hybridization. Halogen connect in vinyl group, halogen connected carbon is a double bonded carbon, therefore sp2 hybridized. Nearby carbon also double bonded, sp2 hybridized. And in the allyl group, you can see chlorine connected carbon is a single bond connected carbon, therefore sp3, double bond connected sp2, double bond connected sp2. Such a way you have to identify whether it contains vinyl or allyl. How? Halogen connected carbon should be sp2, sp2. In allyl mean halogen connected carbon should be sp3, sp2, sp2. This pattern must be there. Let us check it. Where is the position of bromine in the given compound? All of you look into the board. This is the halogen connected carbon. What is the hybridization of this carbon? It is a single bond connected carbons sp3. What is the hybridization of this carbon? It's a double bonded connected sp2. What is this? Double bond connected carbon sp2. See the pattern? sp3, sp2, sp2. Where you can identify that? Allyl group. So what is the position? Allyl group. Okay, very careful. I prefer to choose the allyl and vinyl position by using this hybridization pattern. Okay, next question. Which of the following is a halogen exchange reaction? In this chapter, haloalkane, we study two halogen exchanging reaction. One is called Finkelstein reaction by iodine and Schwarz reaction by fluorine. Okay. Option A, all of you check in. What you have here? RX. RX means R plus and X minus. A haloalkane reacting with the sodium iodide. What is happening, dear student? This X and iodine, the halogen X and iodine is interchanging, right? This is halogen exchange, right? Iodine is exchanging, right? Iodine is substituting here. What is this reaction is called? Iodine substitution is called Finkelstein reaction. Yeah, Finkelstein reaction is a halogen exchanging reaction. Option A itself is correct. You can check with the others that are not halogen exchanging one. Okay, so halogen exchanging reaction, two reactions we are discussing in the chapter. One is Finkelstein, one is Schwarz. Okay, now which of the following example is vicinal dihalide? You know what is meant by vicinal and geminal dihalide? What is meant by vicinal? Vicinal means if the adjacent carbon atom contain two halogens. Adjacent carbon contain two halogen, it is said to be vicinal dihalide. What is meant by geminal? Geminal means the same carbon contain two halogen. Halogens are connected to the same carbon is called geminal. So let us check it. What are the species? Option A given. Option A is given 1,2-dichloroethane. So this is ethane. First and second position chlorine. 1,2-dichloroethane. Yeah, it's vicinal, right? It's vicinal. What is option B? Dichloromethane. Dichloromethane. Methane means only one carbon. It contains two chlorine. So remaining what should be two hydrogen, right? So, but here the single carbon contain both of the chlorine. So, it's a type of geminal. Option C, ethylidene chloride. What is it mean by ethylidene chloride? Ethylidene chloride, dear student, CH3, CHCl, Cl. Ethylidene chloride. You can see here both of the chlorines are on same carbon atom. So what's the point? They are geminal. And what is allyl chloride? Allyl chloride, you know, CH2 double bond, CH single bond, CH2Cl. This is allyl chloride. Only one chlorine, right? So not it belongs to this one. It's a monochlorinated product. Okay, so vicinal dihalide is option no. Now option A is the correct answer. Next one. Which one of the following form propane nitrile as the major product? Very simple. We studied this theory, no? If you treat a haloalkane, for example, I am taking methyl chloride. You studied 4 important reactions here. Hope you studied very well. What are the reagents we are using? We are using KCN, alcoholic potassium cyanide, alcoholic silver cyanide, and potassium nitrate, and AgNO2. You know, different products are getting, right? Why? Because CN is a ambident nucleophile, NO2 is a ambident nucleophile. Both nitrogen and oxygen or carbon and nitrogen can make a connection with the carbon atom. So what is your product? If you treat it with the KCN, you will get CH3CN, cyanide. What? Cyanide. Cyanide is also known as what? Nitrile. Nitrile. If you treat it with AgCN, what you will get? You will get NC, isocyanide or isonitrile. If you treat it with the KNO2, the bonding is with the oxygen, dear student. ONO. That is called nitrite. If you treat it with AgNO2, you will get CH3NO2 nitro. These are the difference. Correct? Okay. So you studied about what is ambident and nucleophile, everything. In the first compound, carbon is connected in CN. In the second compound, nitrogen is connected in CN. This is called what? Ambident and nucleophile. They are having 2 attacking sites. Okay. What we want to get here? Propane nitrile. What is nitrile? Cyanide. Propane nitrile, what is the structure? CH3, CH2, Cn. You know, student, carbon in cyanide group also we will count while taking the parent chain. So total 1, 2, 3 carbon atom. This is the compound propane nitrile or propane cyanide. Okay. I want to get this compound. So what I want to treat? In order to get cyanide, you should use which compound? Potassium cyanide. What is the haloalkane? I can choose it. They are giving propyl bromide, ethyl bromide, propyl bromide, ethyl bromide. Propyl or ethyl can be selected. What? Ethyl. Don't take propyl group, dear. Propyl group already contain 3 carbon. When cyanide comes, it becomes 4 carbon. Your compound become butane nitrile. Okay. So your B and D contain ethyl bromide. What is ethyl bromide? CH3, CH2, Br. Ethyl bromide. Let us treat with the alcoholic KCN. Yeah. What will happen? Bromine and the K is eliminated. CH3, CH2, Cn. You will get it. That is called propane nitrile. Option B is the answer. Can we use AgCN? No. AgCN will give you isocyanide or isonitrile. Okay. Option B is the correct answer. Let's go to the next one. CCl bond in chlorobenzene in comparison to CCl bond in methyl chloride is simple. Carbon chlorine bond in chlorobenzene. Okay, let me take chlorobenzene. This is chlorobenzene. What is the other one? Methyl chloride. Okay, CH3Cl is called methyl chloride. What is happening here, student? Here. What is happening here? You see, here chlorine connected, directly connected carbon. What is the hybridization? What is the hybridization? That carbon is a double bonded carbon, therefore sp2. In a haloalkane, the halogen connected carbon is a single bonded carbon, sp3. Tell me what is the S character in sp2 hybridization? You know, in sp3 hybridization only 25% S character. In sp2 hybridization 33.3% S character. In sp hybridization 50% S character. Why we are discussing S character? Why we are discussing S character? As the S character increases, electronegativity of that element increases. Here we are discussing the hybridization for carbon atom. So carbon, sp2 means I told you 33.3% S is there. In sp3 only 25% S is there. What will happen? Come on. What will happen? What will happen? More the S character, the carbon atom more electronegativity. So it will hold that chlorine very tightly. In this case, the carbon this carbon is more electronegative. It will hold that chlorine very tightly. It won't leave it faster. Haloarene will not undergo nucleophilic substitution reaction faster because you cannot remove the chlorine faster. One more reason, let me tell you, dear student, in chlorobenzene, chlorine contain lone pair, it acts as a donating group on benzene ring, it will cause resonance. After resonance, what is the situation? There is a double bond. On carbon and chlorine. You can see here, there is a double bond between this carbon and chlorine. Come to haloalkane CH3Cl, such a resonance is possible? No, so no double bond. Tell me, this double bond or single bond, which is stronger bond? Double bond is stronger, right? Stronger the bond, shorter length, right? Yes. So what we can say? The CCl bond in chlorobenzene is shorter and stronger than haloalkane. So answer is option B. Okay, clear? Next question. Which of the following carbon atom represent in the molecule given below are asymmetric carbon? Asymmetric means they are said to be chiral carbon atom. Asymmetric carbon means what? Chiral carbon atom. What is a chiral carbon? You studied many times. If the carbon connected, all their valencies are by different group, it is said to be a chiral or asymmetric carbon. You see the carbon 4 bonds are there, it all are connected to different group. Then the carbon is chiral or asymmetric. You can see they specified by A, B, C, D letter. Let's see. The first two, what about option, the carbon A, dear student? This carbon, if you consider, one valency satisfied with the OH group left side. Two valencies are satisfied with the same oxygen. You see, these two valencies are connected to same element. So not chiral. All the 4 bonds should be connected to 4 different groups. So here 2 valencies are connected to the same element. So it is not chiral, it is achiral. So A is not that. Let's go to B. Dear student, the B carbon directly connected to one OH group above, one hydrogen below, one COOH group left side, one CHOH, one big group other side. All are a different group. So we can say B is chiral. Even C also same situation. C is connected to one hydrogen, one OH, one big group here, one big group here. All are different one, so they are chiral. So B and C are chiral. What about C? What about D? In D compound, when you observe, you can see that again the same like the first compound. The 2 valencies are connected to the same element oxygen. So what it is? Achiral. So only B and C carbons are asymmetric or chiral carbon. Option B. Okay, next question. What is the best method for the conversion of an alcohol into alkyl chloride is treating with alcohol with which one? Let me take a alcohol methanol. Okay, methanol. It's an alcohol. How you can convert a alcohol into haloalkane? You can use many things. Right, if you want to convert into, if you want to remove this OH group and if you want to substitute one chlorine, we can use many reagents. What are the things we can use it, dear student? We can use SOCl2, thionyl chloride, SOCl2 can be used, PCl3 can be used, PCl5 can be used, correct? So, SOCl2, PCl3, PCl5, when you treated, product is similar, no doubt. Chlorine, you will get it. But you studied which is the best method. The best method is which one? Thionyl chloride. Why? If you treated with the thionyl chloride, when you treat a alcohol with the thionyl chloride, you will get their haloalkane plus what are the byproduct? Sulfur dioxide and also HCl. You studied that both are gases. Gases can be easily, they are escapable gas, right? They can easily escape from the system. You will get pure methyl chloride or haloalkane. So the best method to convert a alcohol into haloalkane is treating with thionyl chloride SOCl2. But when you treat it with the PCl3 and PCl5, the byproducts are POCl3, H3PO3, like that. They are not all gases. Okay, option which is that A is correct. SOCl2 in presence of pin. Next one. The following compound, what is the IUPAC name? Okay, within the compound, let me explain. Whatever the compound, if you want to write the IUPAC name, first you have to prefer the long chain, parent chain. Which is the parent chain? I think no confusion, we can take the linear one as the parent chain, right? This is your parent chain. So what are the branches you have? One methyl, one methyl, one methyl. Very careful, one double bond is there. Which is the most priority group in this compound? Double bond. Double bond should get least number. So I can start numbering from right side. So number 1, 2, 3, 4, 5. So third position there is a methyl group. Fourth position there are 2 methyl groups. So 3, 4, 4, trimethyl, right? Trimethyl. Total how many carbon in the parent chain? 5 carbon. Therefore, pent, second position, there is a alkene, so pent 2-ene. What's the answer? 3, 4, 4, trimethyl, pent 2-ene. Yes, option A is the correct one. So, IUPAC naming, your term 1 examination, there are 2 organic chapter, haloalkanes and haloarenes with the alcohol, phenol and ether. So from any one of the chapter we can expect one of the question with the IUPAC naming. Okay, let's go to the next question. Okay, next one. What should be the correct IUPAC name for diethyl bromomethane? What is the compound? Diethyl bromomethane. So what is the parent chain? Methane. 1 carbon. That methane contain 1 bromine. Okay, 1 bromine is there. And also it contains diethyl group, 2 ethyl group. So let me place 1 ethyl group above, CH2, CH3, 1 ethyl group below, CH2, CH3. This is the compound, right? 2 ethyl group and 1 bromine on a single carbon, so CH. What is the IUPAC name of this compound? Which is the parent chain? This is the parent chain and bromine. Number 1, 2, 3, 4, 5. So third position bromine on pentane. So what's the name? 3-bromopentane. 3-bromopentane. Where is? Yeah, 3-bromopentane. Option D is the correct answer. A simple question. Next one. Toluene react with the halogen in the presence of iron 3 chloride. What is iron 3 chloride? FeCl3. Giving ortho and para halo compound. This is very important reaction. Very careful all of you. Listen. Toluene, toluene. This is what called the toluene, right? Toluene. Very carefully, this is very important reaction. When toluene react with the toluene can undergo chlorination in 2 ways. What are the 2 ways? First one, you can add chlorine in presence of light. Chlorine in presence of what? Light. We studied already in the beginning question, addition of halogen in presence of light to follow substitution reaction. It to follow free radical substitution reaction. What is happening here? or where this chlorine can be substituted on alkane. Substitution reaction in presence of light preference to react on alkane chain, which is the alkane chain here, CH3 group on benzene. So your product will be take one of the hydrogen from CH3 and substitute one chlorine plus HCl. So what is this compound is called? Benzyl chloride. Benzene with the CH2 is called what? Benzyl chloride. Okay, benzyl chloride. So keep in mind, when toluene react with the halogen in presence of light, it undergo free radical. The mechanism is free radical based one. Therefore, free radical substitution. Let me take another chlorination. Let me add chlorine in presence of a catalyst FeCl3. In presence of the catalyst FeCl3, what can happen? Chlorine in presence of FeCl3, dear student, chlorine when you treated with the FeCl3, Cl2, let me take chlorine molecule like this, ClCl. This is you are treating with the FeCl3. What is happening? No. The FeCl3 is an electron deficient compound. They will try to take this chlorine. They will try to take the chlorine as Cl minus. So this Cl minus ion is taken by FeCl3. So what will happen? You will get FeCl4 minus. FeCl4 minus. So what is the charge of this chlorine? Cl plus. What is the positive charged species are called? Electrophile. What? Positively charged species are electron deficient compound. They are electrophile. So what is happening in this reaction? Cl plus is going to attack electrophile. Electrophile where it is preferred to attack on benzene ring. Okay, on benzene. So what is the product you are getting here? You will get the compound. You will get CH3. No, please don't disturb CH3 group. Please don't disturb CH3 group. And chlorine is going to substitute where? That is depends on the existing group on benzene ring. Methyl group. Alkyl group on benzene ring act as a ortho-para directing group. So the chlorine can attach either to chlorine the ortho position and into the para position. You will get ortho-chlorotoluene and para-chlorotoluene. So keep in mind, in presence of light, if you are adding chlorine, please substitute chlorine on the alkane chain. If you are doing chlorination in presence of a catalyst, it undergo electrophilic substitution reaction. Okay, it will undergo electrophilic substitution reaction. So what is your answer? The question is, toluene react with the halogen in presence of iron 3 chloride FeCl3 in the catalyst what? It will undergo electrophilic substitution reaction. Okay, next one. What is A in the following reaction? What is this reaction, dear all? You can see they given a unsymmetrical alkene. Yes or no? There is an unsymmetrical alkene. You can see this carbon contain 1 hydrogen, this carbon contain 2 hydrogen. You are adding the species HCl. HCl means it contains H plus and Cl minus. And what is happening here? When you are adding a addendum means the adding species, if it contains a positive and a negative charge, here what is the addendum? HCl. HCl contains H plus and Cl minus ion. In the absence of peroxide, they didn't mention any peroxide here. Which rule we have to follow? Markovnikov's addition. Yes, right. Markovnikov's addition. What is Markovnikov's rule? Negative part will goes to carbon contain less number of hydrogen. Positive will goes to more number of hydrogen. What is the product? Chlorine on second carbon. Option B. Option D is the correct answer. Simple Markovnikov addition. Okay, addition of HCl to a unsymmetrical alkene. Next one. Which of the following is the correct for an increasing order of the rate of reaction towards nucleophilic substitution reaction? Okay, what is the species given? Compound number 1 is given as chlorobenzene, just chlorobenzene. Compound number 2 is given as chloronitrobenzene, and the third one is given 2,4,6 trinitrochlorobenzene. Alright, fine. What is the meaning of nucleophilic substitution? A nucleophile is coming. Okay, a nucleophile is coming to this compound. So nucleophile is waiting here where I can react. If a nucleophile want to substitute, first of all, one of the species want to leave from the system. Substitution means what? One of the compound is eliminating, other one is substituting. So which is the best leaving group here? You know, halogen. Halogens are best leaving group, right? So chlorine, here we can remove chlorine. The question, from which compound you can remove chlorine easily, there you can substitute nucleophile easily. So what is the difference here, student? Nitro group present. You know, nitro group is a strong electron withdrawing group, right? Nitro group is a strong electron withdrawing group. Electron withdrawing group presents what can make? You know, electron withdrawing group, they are trying to take completely the electron from the system towards that group. Electron withdrawing group means, you know, first compound doesn't contain electron withdrawing. Second compound contain a electron withdrawing. So they will try to withdraw. Or try to take all the electron from the benzene ring towards it. So what happened? Even from this carbon chlorine bond also, they will try to pull electron. So the carbon chlorine bond become weak. But you see option third one, in option 3, which contain 3 electron withdrawing group. So what will happen? So this nitro group is pulling towards that, this nitro group pulling toward, this nitro group is pulling towards. So from all the benzene ring, nitro groups are pulling electrons towards that. So what happened? The strength of the CCl bond becomes very weak. If it is weak, what will happen? You can easily remove the chlorine. So keep in mind this, or you can keep this point in mind. Electron withdrawing group, if it is present, electron withdrawing group is more present in the system, it will prefer nucleophilic substitution, or it will favor towards nucleophilic substitution reaction. Okay, what is the point? Electron withdrawing group, if it is present, it will favor nucleophilic substitution reaction. Same, electron donating group, if it is present, it will favor electrophilic substitution reaction. So in the third compound contains so many electron withdrawing group, so you can easily remove chlorine, you can easily add or substitute one nucleophile. So 3, 2, 1 is the correct answer. Third one, read the 3, 2, 1, that is option C is the correct answer. Next one. Which of the following, which is the correct IUPAC name of the given compound? What is the compound? CH3, CH. Let me write C2H5 like this. CH2CH3 and CH2Br. What will happen? What will happen here? If you are taking the compound within the given structure, you will make mistake. Try to elaborate it, okay? Now the parent chain changes. What is the parent chain? You can take this is the parent chain, which include bromine. Okay, so what are the branches you have? One methyl is there, one bromine is there. You know, halogen is the most priority one here. As per the existing one, halogen is the highest one. So halogen, let's make lowest number. So number 1, 2, 3, 4. Second position methyl, first position bromo. Alphabetical order, bromine is first. Therefore, 1 bromo, 2 methyl, parent chain contain 4 carbon, butane. 1 bromo, 2 methyl, butane. Option B is the correct. There is a chance to make mistake in the question. Why? If you are calculating the IUPAC name within the given structure, you will take this is the parent chain. Then you will tell that this is ethyl branch. That's wrong, right? Ethyl group means if you are converting the parent chain converted into 4 carbon. Okay, so that is wrong. So correct answer is option B. Let's go to the next one. Arrange the following compound in the increasing order of their rate of reaction towards, again, nucleophilic substitution reaction. Same question. What is the compound? First one is given chlorobenzene. Second one is given chloro with the methyl group on the ortho position. Third one is given chlorobenzene and methyl group is on the meta position. Dear student, just we discussed before one question related to nucleophilic substitution. I told you, if there is an electron withdrawing group more, it will increase the nucleophilic substitution. But unfortunately, here we have which group? Alkyl group. Alkyl groups are which type of group? Electron donating group. So they will decrease the reactivity, right? Electron donating group means they will donate electron towards benzene ring. So carbon, chlorine will get more electron. They become rigid, stronger bond. So you cannot leave chlorine faster. Therefore, you cannot substitute one nucleophile. So when you compare second and third compound, we can definitely say first compound having greater reactivity. First compound. After that, which one? Confusion. Whether the ortho second compound or the meta third compound. Where will be the effect more? Electron donating group, now it is in ortho position, very near to carbon chlorine bond. So what happened? The effect will be greater. So in the second compound, methyl group is on the ortho position. What will happen? It will give more electron towards benzene ring. So carbon chlorine bond become more stronger. You cannot leave chlorine faster. But option third one, meta. Meta position means little away from carbon chlorine bond. So which will be more undergo nucleophilic third one. And least one is for second one. So 1, 3, 2, 1, 3, 2, 1, 3, 2, that is option B. Reason is clear. Electron withdrawing group, if it is present, nucleophilic substitution reaction so faster. Electron donating group, if it is present, very less reactivity. Okay. Next one. What is the decreasing order of reactivity of hydrogen halide acid in the conversion of alcohol into haloalkane? What is the decreasing order of reactivity? You know what is the order of reactivity? Even in P block element chapter also we discussed. What is the reactivity order of hydrogen halide? If you consider the hydrogen halide, what are the halides we have? Fluorine, chlorine, bromine, iodine. Their hydrides mean HF, HCl, HBr, HI. Tell me, dear student, which is the strongest force? Where you can identify the strongest force between HF or HI? No doubt HF. You know, fluorine is the most electronegative element, so the hydrogen bond will be very stronger. So this bond is very strong. This bond is what? Very stronger bond. While you coming down the group, electronegativity of the element decreases because size also increases. So therefore, this bond is very weak. So which bond you can break it so easily? Whether HF or HI? No doubt HI. So it can undergo reaction faster. So among hydrogen halide, HI is more reactive towards most of the reaction because the bond is weaker. So the reactivity order is HI greater than, HBr greater than, HCl greater than HF. Answer is yes, option B. Correct. Down the group, reactivity increases. Next question. In alkyl halide, they given so many data. Okay, let me take a simple example for haloalkane. For example, CH3, CH2, Cl. What is this? Chloroethane or ethyl chloride. Okay, fine. All of this is given. If all of these suppose an answer, it's our duty to check it that whether other options are correct or not. What is option B, dear student? the carbon atom of carbon halogen bond. Okay, where is the carbon halogen bond here? This is carbon halogen bond. Okay, it bears a partial positive charge. The carbon atom in carbon chlorine bond partially positive charge is there. Correct or not? Yes, because chlorine is the most electronegative element. It will carry a partial negative charge. So carbon will carry a partial positive charge. A polarity. That's it. Option B is correct. What is option C? The halogen atom bears a partial negative charge. Yeah, just to be said. Why? Because halogens are electronegative element. They will try to exist in negative state, right? They will take the more electron from carbon chlorine bond, excess negative charge. Option D. So there is a chance to all of these options. Let's take it option D also. The carbon halogen bond of alkyl halide is polarized. Yeah, what is the meaning of polarity? Polarized. They having a charge separation. Because there is an electronegativity difference between carbon and chlorine. Chlorine is more electronegative, therefore it carry negative charge. Carbon is compared to chlorine, positive. So there is polarized. Yes, your answer is all of this. Okay, all of this. Okay, dear all, next question. Arrange the following in the increasing order of their nucleophilicity. What is the meaning of nucleophilicity? Nucleophilicity, we can say in a simple definition, its ability to act as a nucleophile. Simple way we can say its ability to act as a nucleophile. Or you can say nucleophilicity means the tendency of a nucleophile to attack a center of positive charge. You know, nucleophile is a negatively charged or electron rich compound where it will prefer to attack a positive part. Correct? So nucleophilicity means its ability to act as a nucleophile. So among the halogen, bromine, chlorine, iodine is given. Cl minus, Br minus, I minus. Which one can act as a best nucleophile, or which is the best nucleophilicity? Which one having best nucleophilicity? Dear student, iodine having best nucleophilicity. Just we discussed in the previous case, if it is HCl, HBr, HI, this bond will be weak, right? This bond can be break it very fast. It can leave as iodine as I minus ion. It's so easily possible. So the greater nucleophilicity is for iodine, bromine, then chlorine. Option A is the correct one. Okay, nucleophilicity or the expected question. Next one. When a haloalkane with a beta hydrogen atom, what is alpha carbon, beta carbon, they containing hydrogen is called alpha hydrogen, beta hydrogen, etc. Treated with what, dear student? Alcoholic potassium hydroxide, alcoholic KOH. Alcoholic KOH we are using for only one purpose in organic, right? Beta elimination or dehydrohalogenation. Okay. So question, when a haloalkane with a beta hydrogen atom, let me take a haloalkane CH3, CH2, chlorine. What is this compound? Chloroethane. So, this is the halogen present in this compound. Halogen directly connected carbon is called alpha carbon, and alpha carbon containing hydrogen is called alpha hydrogen. So, there are two alpha hydrogen. Alpha carbon directly connected carbon is called beta carbon. Beta carbon containing hydrogen is said to be beta hydrogen. What is mean by what we are treating here? Alcoholic KOH. Alcoholic KOH is the purpose. Beta elimination. What is beta elimination? What is beta elimination? Take the chlorine from alpha carbon. Take a hydrogen from beta carbon, eliminate HCl and make a double bond between alpha and beta carbon. That's it. Take a chlorine from alpha carbon, take one hydrogen from beta carbon, make a double bond between alpha beta. Your product will be CH2 double bond CH2 with HCl. Correct. This is what is happening in beta elimination. Again, option A given all of these. Let us check it. Option B, C, D are possible or not. What is option B? Elimination of halogen atom from alpha carbon. Yes, Halogen is eliminating from alpha carbon. Option C, elimination of hydrogen atom from beta carbon. Yeah, we took hydrogen from beta carbon. Alkene is formed as a product. I told you after the elimination, make a double bond between alpha beta. Yeah, your product is an alkene. All of these are correct for beta elimination. Okay, next one. Which of the following is called Wurtz-Fittig reaction? Let me tell you the theory what we studied. Let me take a haloarene, for example, chlorobenzene or bromobenzene, whatever. What is mean by Fittig reaction? What is mean by Wurtz-Fittig reaction? You know, Fittig reaction mean we will add sodium in presence of diether. Sodium in presence of diether. What will happen if two chlorobenzene are there? When they react together, chlorine eliminated with the sodium, you will get biphenyl, right? The phenyl groups will join together, biphenyl or diphenyl. This is known as what? Fittig reaction, conversion of a haloarene into diphenyl or biphenyl is called what? Fittig reaction. Wurtz-Fittig is small change. What is mean by Wurtz-Fittig reaction? In this case, we are taking sodium in presence of dry ether. So this is same like a Fittig, right? Only one thing is extra. A haloalkane. A haloalkane. For example, CH3Cl, methyl chloride, ethyl chloride, any haloalkane. So what is happening here, you know? The CH3 group is coming instead of chlorine on the ring. So you will get CH3. So you will get toluene. Any alkyl group you can substitute on that benzene ring. This is called what? Wurtz and Fittig reaction. Wurtz-Fittig reaction. So question, which of the following is a Wurtz-Fittig reaction? Simply we can say, what is Wurtz-Fittig reaction? A haloarene reacting with the sodium and dry ether in presence of a haloalkane. The alkyl part is attacking on the benzene ring instead of chlorine. That's or the halogen. Even the starting material is enough to get your answer, right? In Wurtz-Fittig reaction, what is the starting material? A haloarene. Or you can say a haloarene. Option A. See, bromobenzene treating with the sodium in presence of ethyl bromide. So what group is coming here? Ethyl group. What alkyl group we are adding? That alkyl group come instead of the halogen. That's what happened. No, this is not that. This is benzene. No, halogen. That's Wurtz-Fittig reaction. Next one. Which of the following is the correct increasing order of boiling point? Again, boiling point. Let me write the compound in a general skeleton only. What is the first compound? 1-iodobutane. 1-iodobutane. Okay. Second one. 1-bromobutane. Okay. 1-bromobutane. Third one. 1-chlorobutane. Okay. 1-chlorobutane. Option D or the fourth one. Butane. Normal butane. Okay, fine. What is the major difference here on iodine, bromine, chlorine? Even number of carbon also different. Once again, what is the major factor affecting boiling point? Mass. Which one having greatest mass? Iodine, right? Even if you consider fluorine, chlorine, bromine, iodine having bigger mass. So no doubt, first one having greatest boiling point. After that, second bromine, then chlorine. Then least one 4 carbon only, that is the fourth one. So what is the correct order? 1-iodobutane, 1-bromobutane, 1-chlorobutane, butane, that's given in option C. Correct? Very simple question related to boiling point. I think around 3 different type of question we discussed about same concept boiling point. Correct? Next one. Arrange the following compound in the increasing order of their density. You know, density related to what? Mass by volume. So density directly proportional to mass. See, where is which compound having greatest mass? First one pure benzene, second one chlorobenzene, third one dichlorobenzene, the other one bromochlorobenzene. You know, option D, right? D1 having greater, D compound having greater density. Why? Because it contains bromine and chlorine. Their mass is greater, right? Bromine and chlorine. So D having greater. Then which one? Chlorine, chlorine. Two chlorines are there. C. Then one chlorine containing B. Then pure benzene A. So A, B, C, D. Yeah, this is sorry. A, B, C, D. Right. So D having greater. D having greater. That's only given option D. D having greater. That's only in D. Next one. Molecules whose mirror images is non-superimposable over them are known as chiral. Which of the following molecule is chiral in nature? You know, chirality we are checking by carbon connected 4 valency with 4 different groups. Let us check it. Option A. 2-bromo-propan-2-ol. 2-bromo-propan-2-ol. Okay, this is one of the compound. Option B, what it is? 2-bromopropane. 2-bromopropane. Okay. What is the option C compound? 2-bromobutane. 2-bromobutane. Okay. And what is the last one, dear all? 1-bromobutane. 1-bromobutane. Okay. 1-bromobutane. Fine. Check it here all. Which one having a chiral carbon atom? First compound contain chiral? No. If you consider this carbon atom, it is directly connected to same methyl group. All of the groups should be different. If you consider the second compound, this carbon atom, it is directly converted to 2 same group. No. If you consider this carbon atom, it is connected to 1 bromine atom, 1 methyl group, 1 ethyl group, and 1 hydrogen. Yes, all are different group. Therefore, this carbon is said to be chiral. And option D, all carbons are achiral. So, what is that? Option C is the answer. 2-bromobutane. Right? 2-bromobutane is the correct answer. Next one, all of you. Vinylic halide containing. What is vinyl group? What is vinyl group? CH2 double bond, CH single bond. This is called vinyl group with a halogen. Suppose you consider chlorine, vinyl chloride. Okay. We already discussed what is the hybridization and how to find out whether it is a vinyl group or not. If the halogen connected carbon or the functional group connected carbon, what is this? It's a double bond carbon, sp2. This is also double bonded carbon, sp2. So halogen connected carbons are sp2, then we can call the what it is a vinyl group. So option A. sp3 hybridized carbon atom. No. Which is that? Halogen and what is option B? Halogen atom bonded to an sp2 hybridized carbon atom of a carbon-carbon double bond. Yes. Correct. sp2 is the connector. What is option D? sp2 hybridized carbon atom of an aromatic ring. No, it should be linear chains, normal. This is sp3. No, option B is the correct. The reaction of toluene. This reaction already we discussed. Toluene. What is toluene? You know, benzene with the CH3. Toluene react with which compound here all? Chlorine in presence of iron. It is reacting with the chlorine in presence of iron. We studied 2 chlorination on toluene, right? One is chlorine in presence of light, where chlorine will add on CH3 group. One is chlorine in presence of catalyst. Here the catalyst is given Fe, or they will give you FeCl3. So during addition of chlorine in presence of a catalyst, what you have to take? Electrophile. Which electrophile is coming? Cl+. Where it is adding ortho and para product, because CH3 group is a ortho para directing group. So substitute 1 chlorine on ortho position, ortho chlorotoluene, 1 chlorine on para position, para chlorotoluene. So your answer is of course option A, mixture of ortho chlorotoluene, para chlorotoluene. Option A is the correct. Okay, very careful. Next one. Methyl bromide. Very simple question. Come on. Methyl bromide CH3Br converted into ethane. Ethane. Come on. Simple. Bromomethane. Right. Methyl bromide treating and converting into double carbon. Double double the carbon atom in the parent chain, in the product. If you want to double the carbon, which reaction? Wurtz reaction, correct? We will take the same two molecule, we will treat it with the 2 sodium metal in presence of dry ether, CH2, CH3, CH3 group will combine together, you will get ethane. So what is this called? Wurtz reaction. The metal preference is for sodium. Okay, next one. Carbon tetrachloride has a dipole moment. It's a question connecting your 11th grade. What is carbon tetrachloride? CCl4. Correct, CCl4. Carbon, what is the structure of CCl4? Tetrahedral geometry, right? CCl, Cl, 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 tetrahedral geometry. You know, chlorine is the most electronegative element. You know the dipole moment, how to draw. Chlorine is more electronegative, so you can draw the diagram towards that. So chlorine here, down, chlorine here, down, chlorine here, this. Or you can say, if it is a tetrahedral geometry, all the surrounding 4 elements are similar, their dipole moment will be 0. All of them will cancel each other. So this is the point, all of you. In a tetrahedral geometry, all the surrounding elements, if they are similar, when only similar, their dipole moment nu will be cancel each other, 0. So it is a non-polar molecule, dipole moment 0. So carbon tetrachloride, dipole moment is 0. Option A is the one. Next one, dear on, what is the IUPAC name of CH3 thrice CCl? Let me just expand the formula. What is the common name of this compound? What is CH3 thrice C? Terbutyl chloride. Once again, I am reminding you. Isopropane, isobutane, neopentane, terbutyl, all are common name. Okay, don't use in IUPAC. Let me just elaborate the structure. CH3, CH3, CH3 with chlorine. What is the name here all? Select the longest chain. Okay, this is the longest chain. Methyl chlorine. So what is this? Number 1, number 2, number 3. Second position is chlorine, second position methyl. Alphabetical chlorine is first. Therefore, 2-chloro, 2-methyl propane. 2-chloro, 2-methyl propane. That is the answer. 2-chloro, 2-methyl propane. 2-chloro, 2-methyl propane. Yeah, option D is the correct one. Next, to prepare alkanes containing odd number of carbon atom, Wurtz reaction is not preferred. Yes or no? For example, let me take a methyl chloride, 2 molecules of methyl chloride. Let me treat it with the sodium metal in presence of dry ether. What will happen? These 2 sodium will take these 2 chlorine atom and they will eliminate NaCl. And what is the major product? CH3 single bond, CH3. Ethane. How many carbon atom in the product? 2 carbon, even number. Let me take another haloalkane, for example, ethyl chloride, CH3, CH2, Cl. One more ethyl chloride, CH3, CH2, Cl. Okay, let me treat with the 2 sodium metal. What will happen? The 2 sodium will remove this 2 chlorine, and this CH3, CH2, CH3, CH2 will combine together. We will get butane. Yes or no? We will get butane. How many carbon in the product butane? 4 carbon. You know, Wurtz reaction we can use only to prepare even number of carbon in the parent chain. Odd number we cannot make it. Only even number carbon we can make it. Now come to the question once again. To prepare alkane containing odd number of carbon atom, what we have to do? You studied in 11th grade, there is a demerit of Wurtz reaction. Then you have to take if you want to get a odd number of carbon in the product, you have to use 2 different haloalkane. In these 2 cases, we are taking same haloalkane, right? Methyl chloride with the methyl chloride, ethyl chloride with the ethyl chloride. If you want to get odd number of carbon in the product, use 2 different haloalkanes. For example, methyl chloride with the ethyl chloride. Ethyl chloride. What will happen if you treat it with the 2 sodium? 2 sodium will delete this or remove this 2 chlorine. this methyl and ethyl will combine together, we will get propane. Now the propane contains 3 carbon. Even though you will get a mixture of product here, it is not a pure method. Okay, so if you want to get odd number of carbon atom, what we have to do in Wurtz reaction? A mixture of 2 different alkyl halide has to be used. We have to use 2 different haloalkane. Okay, clear here? Okay, next question. Ethylidene chloride is we discussed ethylidene chloride in one of the vicinal question. What is mean by ethylidene chloride? I told you CH3, CHClCl, this is called ethylidene chloride. CH3, CHClCl is called ethylidene chloride. Here you can see both of the halogens are present on the same carbon atom. What it is called? Geminal. Right? It's called geminal dihalide. Ethylidene dichloride is ethylidene chloride is a geminal dihalide. Okay? Next one. Reaction of what is this compound? What is this compound? C6H5 phenyl with CH2. So benzyl bromide. What is this compound? Benzyl bromide reacting with the aqueous sodium hydroxide. What we are treating here? Sodium hydroxide. Benzyl bromide we are treating with sodium hydroxide. It follows which reaction? It follows which reaction? Dear student, they mention the most important term here, aqueous. Aqueous, the medium is aqueous, water is there. You studied that SN1 mechanism favor. SN1 mechanism takes place more in polar protic solvent. Studied or not? SN1 mechanism takes place more in polar protic solvent, whereas SN2 mechanism favor polar aprotic solvent. So dear all, what all are polar protic solvent? Which are the example for polar protic solvent? Polar protic solvent example, water, alcohol, ethanol, methanol, etc. Water, if it is given water or alcohol medium, keep in mind here all, you can prefer SN1 mechanism. What is polar aprotic solvent? Polar aprotic solvents are acetone, propanol. Acetone is a polar aprotic solvent. Another example, DMF, dimethyl formamide, DMF. Another example, DMSO, dimethyl sulfoxide. Okay, acetone, dimethyl formamide, dimethyl sulfoxide. In these kind of solvents, you can perform SN2 mechanism faster. Come to the question, they given aqueous. Aqueous mean water. In water medium, which reaction favor? SN1 mechanism is favor. Okay, answer is option A. SN1 mechanism favor. Next one. Which of the following alkyl halide will undergo SN1 reaction most easily? SN1 reaction order very well, tertiary greater than, secondary greater than primary for haloalkane. Correct. But what is the problem? Here all haloalkanes are tertiary. In such cases, what you have to check is which halogen can leave easily fast. Okay. Dear student, this is bonded with the iodine, this is with the bromine, this is with the fluorine, this is with the chlorine. We discussed that iodine having high nucleophilicity, which means this iodine is bigger in size, because of bigger size, this bond is very weak. This bond is very weak. So it will give the carbocation immediately. What is the first step in SN1 mechanism? Elimination of halogen and formation of carbocation. Let me just write the structure of the first compound. Okay, CH3 and we have iodine. What is the first step? The slowest step in SN1 mechanism? Removal of halogen. Halogen is leaving as which one? I-. So what you are getting? A carbocation, a tertiary carbocation, right? More stable, right? Carbocation. This is what are the first step. So which will undergo SN1 reaction faster mean first you go through this order. If all are given secondary, all are given tertiary mean you check it where you can leave the halogen so easily. Iodine is the best leaving group. Yeah, it can form carbocation immediately. So option A is the correct answer. Okay, next one. Which of the following is a primary halide? Which of the following is a primary halide? Okay, option A. What is isopropyl group? One CH group connected to 2 CH3 group is called isopropyl iodide. Option B. Sec-butyl. What is sec-butyl? CH3CH2 CHCH3. This is called sec-butyl iodide. Option C. Tert-butyl. One carbon connected to 3 methyl group is called tert-butyl bromide. Okay. Option D. Neohexyl. What is neohexyl group? This is called tert-butyl. Tert-butyl with one more carbon is called neopentyl. One more carbon is called neohexyl with chloride. Which is a primary haloalkane. How to identify primary, secondary, tertiary? Halogen connected carbon, if it directly connected to only one carbon, primary. Halogen connected carbon, if it directly connected to 2 carbon, secondary. Halogen connected carbon, if it directly connected to 3 carbon atom, tertiary. All of you see the first compound here, halogen connected carbon directly connected to 2 carbon, primary. Option B, halogen connected carbon directly connected to 2 carbon, secondary. Sorry, the first one is secondary, no? Yeah, connected carbon 2. Okay. Option C, halogen connected carbon directly connected to 3 carbon, tertiary. Here halogen connected carbon directly connected to 1 carbon, primary. Answer is option D. Neohexyl chloride. Okay. Next one. Classify the following compound as primary, secondary and tertiary. First compound, 1 bromo but 2-ene. But 2-ene, 1 bromo. Okay. Second compound, 4 bromo pent 2-ene. Pent 5 carbon. 4 bromo pent 2-ene. Okay. Third carbon. 2 bromo 2 methyl propane. Okay, 2 bromo 2 methyl propane. Fine. Here all, check it please. Check it please. Here the bromine connected carbon directly connected to 1 carbon, primary. Here bromine connected carbon directly connected to 2 carbon, secondary. Here bromine connected carbon directly connected to 3 carbon, tertiary. So one is primary, secondary, tertiary. Correct order. So answer is which one? Primary, secondary, tertiary. Option D. So simple to identify primary. Correct. Next. Which of the following is not an allylic halide? You know what is allyl group I told you? CH2 double bond, CH single bond, CH2, Cl. This is allyl chloride. How to identify? Halogen connected carbon is sp3. This is sp2. This is again sp2. This is the way. Okay, let's see. Option A. I'm just writing the skeleton structure. 4 bromo pent 2-ene. Pent means 5 carbon atom. Fourth position bromine pent 2-ene. Correct. B compound. 3 bromo 2 methyl but 1-ene. But 1-ene 3 bromo and 2 methyl. Okay. Option C. 1 bromo but 2-ene. 1 bromo but 2-ene. And option D is 4 bromo but 1-ene. 4 bromo but 1-ene. Okay. Which is an allyl carbon or allylic, not an allylic one. Okay. First one bromine. This carbon is single bond, therefore sp3, double bond carbon, sp2, double bond carbon, sp2. Yeah, it contains allyl group. Correct. So not this answer. Option B, bromine connected carbon. See, this is sp3. This is double bonded carbon sp2. This is double bonded carbon sp2. Yeah, it contains allyl group. So not the answer, which is not allylic. Next one, bromine connected carbon. This is sp3. This is double bond sp2. This is double bond sp2. So what it is? Yeah, it is allylic. What about option D? Bromine connected carbon sp3, but nearby carbon also single bonded carbon sp3. No, sp3, sp3 not there, sp3, sp2, sp2 has to come. So option D is the answer. Correct? Next one. Haloalkanes contain halogen atom attached to a sp3 hybridized carbon atom of an alkyl group. Yeah. Identify haloalkane from the following compound. Okay, first compound 2-bromopentane. 2-bromopentane. Second one, vinyl chloride. What is vinyl group? CH2 double bond, CH single bond chloride. What is option third one? 2-chloroacetophenone. What is acetophenone, dear all? Benzene with the COCH3. 2-chloro. Okay, 2-chloro. What is option D? Trichloromethane. CHCl3. Trichloromethane. Chloroform. Which is haloalkane? That is the question. Which of the following is a haloalkane? What is a haloalkane? Simple, if you consider methyl chloride. Halogen connected carbon is sp3. You see, here the halogen connected carbon is a single bonded carbon sp3. Therefore, it is a haloalkane. Here halogen connected carbon is a double bonded carbon sp2. So, it is not haloalkane. Here halogen connected carbon is a double bond, right? How to write the benzene ring? Benzene ring we can write like this. See, this is a double bonded carbon sp2. So, not that. CHCl3, full single bonds, right? CHCl3, all are single bond. So, this carbon is sp3. Yes. So, compound number 1 and 4th one. 1 and 4th one are haloalkanes. Okay? Haloalkanes. Next one. What is the IUPAC name of tertiary butyl chloride? We already discussed in one another question in another way. What is tertiary butyl? 1 carbon connected to 3 methyl group. This is called tertiary butyl chloride. What is the IUPAC name? Select the longest chain. Identify the branches. Put the number. Second position there is a chlorine. Second position there is a methyl. Therefore, 2-chloro. 2-methyl, 2-chloro, 2-methyl propane. So, answer is 2-chloro, 2-methyl propane, 2-chloro, 2-methyl propane. Yeah, option 1 itself. So, common name important to study. Next, what is the IUPAC name of this given compound? CH3 twice on CH. Therefore, CH3 on CH carbon, there are 2 CH3, then CH2, then CH2, then Br. Simple. Select the longest chain. You can take it. This is the longest chain. Methyl is there. Bromine is there. Bromine is the highest priority among this one. So let's make it lowest number. 1, 2, 3, 4. First position bromine. Therefore 1 bromo. Third position methyl. Therefore 3 methyl. And we have butane. Okay, butane. You can pause the video if you want to see the answer very carefully. Okay, after the explanation, pause the video. Just check it, answer is correct or not once again. 1 bromo, 3 methyl, butane. 1 bromo, 3 methyl, butane. Option B is the correct one. Next. Match the, column number 1, they given some structure. Column number 2, we want to write identify the IUPAC. Very simple, if match the column number if they asking. Because one answer, maybe first one, you can match it with any of the column 2. Maybe the answer will be there without any mistakes. What is the answer for this compound number 1? This is your parent chain. Bromine should get least number. Therefore, 1, 2, 3, 4, 5. So, second position there is a bromine on 5 carbon pentane chain. So, name is 2-bromopentane. 2-bromopentane. Where you can identify, dear student? A with the second one. A with the second one. A with the second one. Only one answer is the option B. You can check remaining are correct or not. Okay, later you can correct it. Just to pause the video, you can do it. Next one. Which of the following compound can yield only one monochlorinated product upon free radical chlorination? Chlorination in presence of sunlight. Option A. 2,2-dimethyl propane. 2,2-dimethyl propane. Correct. 2,2-dimethyl propane. What is chlorination? Addition of chlorine in presence of sunlight or UV light. What is happening during free radical substitution? One of the hydrogen you want to take from alkane chain and one of the chlorine you want to substitute. That's it. So I will get the product like CH3, 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 CH2, Cl. Yes or no? This is the product you are going to get. Monochlorinated. Monochlorinated means you should add only one chlorine at a time. In the compound, it should contain only one chlorine. Dear all, this product I am getting if I am taking a hydrogen from this carbon. Correct. If I am taking a hydrogen from this carbon, what will be the situation? You will get this product CH3C, CH2Cl, CH3, CH3. But these and these both are same product, right? Check it. Both are same product, right? If you take hydrogen from these or this also, you will get only one compound. You will get only one compound. So what is the question? Which of the following compound can yield only one chlorine containing just one product? That is only option A. Option A. Okay. B. A is the correct answer. Next one. Bromination of methane in presence of sunlight is. What is methane? CH4. Bromination Br2 in presence of light. Addition of halogen in presence of light is follow. What is happening? Take one hydrogen, substitute one bromine. You will get CH3 Br with the HBr. What is this reaction is called? Substitution. Which substitution? It is following free radical mechanism. Okay, in presence of light, the preference is free radical mechanism. So what we can say? Free radical substitution. Option B is the correct one. Addition of halogen in presence of light to follow. Underline free radical substitution. Now, a compound X. They given a compound X. What is the molecular formula of X? C7H8. You can confirm it is an aromatic ring. Why? Because there is no most difference in carbon and hydrogen number. Okay. It is treated with chlorine. Okay, it is treated with chlorine in presence of what? Catalyst FeCl3. So where the chlorine is adding on benzene ring. Which of the following compound are formed during the following reaction? You can able to understand what is your compound C7H8 by the following option. Toluene. All of the option contain toluene. You can check it toluene formula correct or not. C7H8. I told you already, toluene when treated with chlorine in presence of FeCl3, electrophile is coming. Which electrophile? Cl+. Where it will go? Ortho and para position. Why it is so? Because CH3 is a ortho para directing ring. So what is the product here all? CH3 chlorine ortho position and CH3 chlorine on para position. Correct? So what is your answer? Which of the following products are formed? No doubt, option A itself. Orthochlorotoluene, parachlorotoluene. Simple thing. Next, a very simple reaction. Your starting material is aniline. Your starting material is which one here all? Aniline NH2. Aniline treating with which one? NaNO2 with the HCl under 0 to 5 degrees Celsius. Name the reaction. Aniline Diazotization, you will get which compound? Benzene diazonium chloride N2 plus Cl minus. What they are treating? So this is your compound X. What they are treating dear all? Check it. Treating with the potassium iodide Ki. What happened when they treated with the potassium iodide? This K plus and Cl minus eliminated as KCl. Iodine will substitute on benzene ring. You will get iodobenzene with the KCl with the nitrogen gas. So iodobenzene conversion. So this is a compound Y. A benzene diazonium chloride. You can convert it into iodobenzene just to warm with the potassium iodide. So your X compound is diazonium chloride. Y compound is iodobenzene. Option A is the correct answer. Correct. We studied under Sandmeyer, Gattermann after we discussed this kind of questions. Correct. Now, the negative, very simple question. The negative part of the addendum. Addendum means the adding species. Add to the carbon atom of the double bond containing the least number of hydrogen atom. The rule is known as which one, dear student? Markovnikov's rule. If the addition compound contain, the adding compound contain positive and negative part will goes to carbon with less hydrogen, positive will goes to carbon with a greater number of hydrogen is followed by Markovnikov addition. Is it peroxide rule is also given? Okay, what is called the peroxide rule? Peroxide effect is also known as Kharash effect or anti-Markovnikov rule. Let me check it once again. Carbon atom of the double bond containing least number of hydrogen atom. Yeah, negative part is adding to least number of hydrogen atom, that is Markovnikov rule itself. Correct. Then, which of the following reaction follow Markovnikov rule? What is option A? C2H4. What is C2H4? Ethene with a HBr. What is option B? C3H6. This is propene. Propene treating with which one? Cl2. What is option C? C3H6. Again, propene with the HBr. What is option D? C3H6. Again, propene. With which one? Br. Question, what is that? Which of the following reaction follow Markovnikov rule? Which will follow Markovnikov rule? Markovnikov rule means the alkene should be an unsymmetrical alkene. Option A we can cut it because option A is a symmetrical alkene. What is a symmetrical alkene? Both double bond carbon contain equal number of hydrogen. It's a symmetrical, not takes place. B, C, D or can be the answer. I can cut option B and option D. Why? Because Markovnikov anti-Markovnikov rule, the adding species should contain positive and negative part. You know, B, what is the adding species here? Cl2, chlorine, chlorine, both are same element, right? No charges. Bromine, bromine, Br, both are same, right? No charges. But in HBr we have H plus and Br minus. Addendum should contain negative and positive. What is happening? Negative part comes to carbon with less number, positive part comes to carbon with the more number of hydrogen. So your Markovnikov rule is only applicable in option C. Correct? Simple question. Next one, dear all, methyl bromide. Come on fast. Methyl bromide. What is methyl bromide? CH3Br. React with the AgF. I hope you get the answer immediately. Silver fluoride. What is happening? This is CH3 plus Br minus. This is Ag plus F minus. Double displacement. You will get CH3F and AgBr. What is happening here? Bromine is exchanged by fluorine. Halogen exchanging reaction with the fluorine is known as Schwarz reaction. Correct? Schwarz reaction. Schwarz reaction. What about Finkelstein? Finkelstein with the iodine. Okay, Finkelstein with the iodine. Okay, next one. Which of the following molecule has highest dipole moment? Dipole moment, one question we discussed in CCl4. One another question. Option A, CH3Cl. Structure, all their structures are tetrahedral. Okay, tetrahedral. Option B, CH2Cl2. CH2Cl2. Option C, CHCl3. CHCl3. And option D, CCl4. I told you before, in a tetrahedral molecule, all the surrounding elements, suppose they are similar, their dipole moment will be 0. So no doubt. Which of the following having highest dipole moment? That is the question. Okay, let's see. What about option A, dear all? In option A, if you take carbon and chlorine bond, chlorine is more electronegative, so it will pull electron towards up. Carbon and hydrogen, when you consider, carbon is more electronegative, so what is happening here? All the dipole moments are adding in the same direction. All dipole moments are adding up in the same direction. So what will happen? It having greater dipole moment. Your answer can be option A. What about option B and C? This chlorine pull up, this chlorine pull little bit down. Something cancellation. Then here chlorine up, this chlorine down. Cancellation. All are adding up only in one option. That is option A, CH3Cl. It having greater dipole moment. Next one. Which of the following having highest boiling point? Many questions we discussed about boiling point. Tell me dear. First compound CH3, CH2, CH2, Cl, all are linear 3 carbon. B contain 4 carbon with 1 chlorine. C contain 1 branch. What is the CH3 given in bracket? A branch. D, I think the same question we discussed right before. Which one having greatest boiling point? B. Because it contains total 4 carbon atom with 1 chlorine. All are in the same straight chain. Surface area greater, no branching. Option C and D, you can see branchings are coming. Branching comes, boiling point decreases. So highest boiling point is for option B. Arrange the following compound in the decreasing order of boiling point. Very simple question. You have no doubt here. Bromine, 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 bromine. All halogens are similar. You know the main factor affecting boiling point is which one? Mass. Which one having greatest mass? Last compound, because they contain 4 carbon. Here 3 carbon, here 2 carbon, just 1 carbon. So fourth one having greater, third one, second one, first one. 4, 3, 2, 1, 4, 3, 2, 1. That is option B. Right? Okay. So maximum question related to boiling point is completed. Next one. Which of the following compound will show highest melting point? One of the question already I given the clue. Highest melting point. What is the compound here all of you? Option A is chlorobenzene. B is ortho-dichloro, meta-dichloro, para-dichloro. Anyway, chlorobenzene we can cancel because other option B, C, D contain 2 chlorine atom. Density greater? No. So melting point greater. Among ortho, meta, para, I told you what is the order of melting and boiling point. Do you remember? Melting point order, what do you have to remember? POM. P greater than O greater than M. Para greater, ortho greater, meta. And in boiling point, what I told you to do that? Melting point, POM. Boiling point, what I told you, just interchange the first two. Ortho, para, meta. This is the order. So which one having highest melting point? That is for para. We said no. Para products having greater symmetry. They will occupy in the crystal lattice very tightly. Therefore, they are reaching one high melting point. Okay. Next. Choose the correct increasing order of the density. Density depends on mass. Which one having greater density, dear all? You can check the masses. First carbon with a 4 chlorine atom. 4 chlorine. Okay. Here 1 carbon, 2 hydrogen, 2 chlorine only. Here 3 carbon, 7 hydrogen, 1 iodine. Here 3 carbon, 7 hydrogen, 1 chlorine. All of you check it. Definitely option A can be the answer because they are having greatest number of mass. Because it is carbon with a 4 chlorine atom. Greater mass will be there. Okay, you can check it. Alkyl halides are immiscible in water though they are polar molecule. We studied a theory called like dissolves like. Polar molecule can dissolve in polar solvent. Water is polar, haloalkane also polar. So as per the theory it should be dissolved. But haloalkane, if you consider methyl chloride, chlorine carries a partial negative, carbon carry a partial positive, they are polar molecule. Even though they are polar, they are not soluble in water. Why? If a substance wants to soluble in water, they should have an ability to make hydrogen bonding with the water. So here you can say that they cannot form hydrogen bond. They cannot form hydrogen bond with the water. Option B is the correct answer. Haloalkanes, even though they are polar, maybe assertion reason can expect the question. Okay. Even haloalkanes are polar molecule, they are not soluble in this water because they cannot make hydrogen bond with water. Okay, next one. Cyanide ion act as a ambident nucleophile. No, cyanide, nitro, all are ambident nucleophile. From which end it acts as a stronger nucleophile in aqueous medium? Dear student, Cn. This is cyanide. Either carbon can make a bond with another carbon or nitrogen can make a bond with another carbon. If carbon making bond is called cyanide, nitrogen making bond is called what? Isocyanide. Correct. Which is more strong? Which end, whether carbon end or nitrogen end in cyanide can act as very strong nucleophile in aqueous medium? The student, answer is carbon end, because aqueous medium, the medium carbon-carbon bond which is stronger than carbon-nitrogen bond. Okay, carbon-carbon bond is more stronger than, more covalent and stronger than carbon-nitrogen bond. So we can say it acts as a stronger nucleophile from carbon end. Carbon end is the better for making a nucleophilic center. Identify the product A and B in the following reaction. A haloalkane is given with a silver cyanide. A haloalkane is given with a potassium cyanide. We studied that when a haloalkane treated with a potassium cyanide, you will get cyanide, alkyl cyanide. When you treat it with the AgCN, we will get isocyanide. Yes or no? When you treat it with the KCN, product is cyanide. When you treat it with the AgCN, product is isocyanide. So what is the answer? First is isocyanide, second one is cyanide. Option C. Isocyanide, correct, right? Isocyanide and cyanide, yes. Butane nitrile can be prepared by the reaction we already discussed. What is butane nitrile? One another question we discussed before, another compound. Butane nitrile. Butane nitrile means cyanide. Total 4 carbon including cyanide. So therefore CH3, CH2, CH2. This compound you have to prepare. For that to get this cyanide, what compound you have to treat with the KCN? As I told you, total this compound contain 4 carbon, butane nitrile. So cyanide already you are getting from Cn. So how much carbon in left side? 3 carbon. Right. So it should be CH3, CH2, CH2. It should be a haloalkane, right? Okay, chlorine. Propyl chloride. Propyl alcohol. No, alcohol we are not using. Butyl not possible. Yeah, propyl chloride with the KCN. Option D is the correct one. Propyl chloride treating with this KCN will eliminate. You will get the product. Next one. Ethyl alcohol. What is ethyl alcohol? CH3, CH2, COH. Ethyl alcohol is obtained from ethyl chloride is boiled with which compound? Ethyl chloride, okay. Ethyl chloride is the starting material. From this compound, we want to prepare ethyl alcohol. What we are using the normal reagent. If you want to remove chlorine, if you want to substitute OH group, what we are using? Aqueous KOH. Correct. Nucleophilic substitution. Cl is removing, OH nucleophilic substituting. Aqueous KOH is the one. Why we are not using alcoholic? Alcoholic KOH will prefer beta elimination. It will give you alkene. Okay. Aqueous KOH is the best one for the conversion. Which of the following alkyl halide undergo hydrolysis with the aqueous KOH at the fastest rate? They are indirectly asking something. Which of the following haloalkane undergo hydrolysis reaction with the aqueous KOH? What I told you, aqueous. Aqueous mean which reaction prefer? SN1 mechanism, polar protic solvent. SN1, what is the reactivity order of SN1, dear all? Tertiary greater than, secondary greater than, primary. Identify which one? Option A. Option A is a primary haloalkane, right? Chlorine connected carbon directly connected to one carbon, primary. Option B. Chlorine connected carbon directly connected to one carbon, primary. No, we need tertiary or secondary. Option C again primary. Option D secondary. Why option D secondary? CH3, CH2, CHBr, single bond CH3. This is the combo. See here, bromine connected carbon directly connected to 2 carbon. Therefore, it is what? Secondary. So, secondary is more preferred than primary. Answer is option D. Okay, aqueous medium. If they given, all of you try to follow which rule SN1 mechanism. Okay, next one. The alkyl halide is converted into an alcohol by, just we discuss now. A alkyl halide, for example, methyl chloride, you can convert it into methanol. What is the name of this reaction? One halogen is removing, OH minus nucleophile is substituting. What it is called? Nucleophilic substitution. Substitution reaction. SN2 reaction, the sequence of bond breaking and bond formation is as follows. You know, SN2 mechanism, you study the diagram and everything. You know, in SN2 mechanism, there is a halo groups like this one, right? Haloalkane is there. In SN2 mechanism, what is happening? The first step itself, nucleophile is attacking to the carbon atom to the opposite side of halogen present. Nucleophile is attacking. Therefore, in SN2 mechanism, primary undergo reaction faster. Less steric crowded should be the haloalkane. So what is happening? You are getting an intermediate, right? Nucleophile is attacking, halogen is leaving. It will take within the same step itself. You know, SN2 mechanism takes place in one step. Nucleophile is attacking, at the same time halogen is leaving. So what is the answer? SN2 reaction, the sequence of bond breaking and bond formation. Which bond is going to break here? The bond which is going to break is this one, right? Carbon halogen bond. Which bond is going to form here? Carbon nucleophile bond. Alright. So what we can say? Bond breaking, option C can be right. Bond breaking and bond formation occur simultaneously. When the nucleophile attack, at the same time, the halogen try to leave it. Which of the following statement is not correct about SN2 mechanism in haloalkane? Option A. Nucleophile attack the carbon from the side opposite to where the leaving group present. Correct. Where is halogen present? The nucleophile is attacking to the opposite side. Correct one. The bond formation and bond breaking takes place in one step. Yeah, in a single step simultaneously it will happen. Option C. Rate of reaction depend upon the concentration of the nucleophile. Yes or no? Because you know, this is the reaction, this is the slowest step. Okay, first one is the fastest and you know it is forming an intermediate everything. Anyway, this is a alkyl halide and this is the nucleophile. So the rate of the reaction depends on reactant concentration. What are the reactant? So we can say rate is directly proportional to alkyl halide concentration and also the nucleophile concentration. So rate is depends on speed of the reaction depends on which one? Reactants, right? Nucleophile is a reactant. Correct. SN2 mechanism is predominant in tertiary. No, in tertiary steric hindrance is maximum. Primary will undergo, you know, SN2 reaction. What is the reactivity order? Primary greater than, secondary greater than tertiary. Tertiary it is incorrect. Option D is the correct answer. Then the reaction given below. Which reaction is this? Whether SN1 or SN2? How to identify? So simple. This is a haloalkane, correct? Haloalkane. This is the nucleophile. Okay. You please observe the haloalkane initially and the alcohol finally. Initially, the haloalkane is like this, correct? Like this. After the reaction, they inverted. You studied very well, dear student. In SN1 mechanism, there is a retention of configuration. There is a retention of configuration. If the initial structure is, if the initial haloalkane is like this, the halogen will go, nucleophile substitute, final product also like this. Retention, the configuration will remain the same. Retention of configuration. But in SN2 mechanism you studied Walden inversion. There is a inversion of configuration. Inversion of configuration. If it is the haloalkane initially like this, finally when nucleophile substitute, it will be like this. Inversion of configuration. Walden inversion, that is the correct name. And one more thing, let me tell you, where is racemization happening? Where you will get racemic mixture, equal quantity of dextro and levo in SN1. Keep in mind, SN1 mechanism, there is a retention of configuration and also you will get a racemic mixture. Which one? A racemic mixture. Okay, racemic mixture. So come to the question. So what is this? Initially in this structure you can see all are like this. but finally inverted. So there is an inversion. Inversion corresponds to SN2 mechanism. So reaction proceed via SN2 mechanism, hence inversion of configuration is happening. Option A is the correct one. Next one. Tertiary alkyl halide are practically inert to SN2. Yes. What is a tertiary group? Halogen connected carbon directly connected to 3 carbonate. This is what tertiary. You know, CH3 groups are very bulky group, very bulky. Where is nucleophile attacking in SN2 mechanism? Opposite side of the nucleophile. If there are bulky group present, steric hindrance is maximum, crowdiness is maximum. So nucleophile can attack? No. So what is the major reason in tertiary SN2 mechanism not possible? Due to steric hindrance. Due to steric hindrance and crowdiness. Now, among the choice of alkyl bromide, least reactive bromide in SN2 mechanism. Least reactive. What is the reactivity order of SN2 mechanism? Primary greater than, secondary greater than tertiary. Option A. 1-bromopentane. 1-bromopentane. Option 2. 2-bromo, 2-methyl-butane. 2-bromo, 2-methyl-butane. 1-bromo, 3-methyl-butane. 1-bromo, 3-methyl-butane. Okay. What is option D? 1-bromo, 2-methyl-butane. 1-bromo, sorry, 3. Okay, 1-bromo. Okay, right? 1-bromo. Structures are correct or not? Check it. Okay. 1-bromo, 3-methyl-butane. 1-bromo, 2-methyl. 1-bromo, 2-methyl. 1-bromo, 2-methyl. Okay. Question: which is least reactive towards SN2? Here bromine connected carbon directly connected to 1 carbon, therefore primary. Here bromine connected carbon directly connected to 3 carbon, tertiary. Here bromine connected carbon directly connected to 1 carbon, primary. Here bromine connected carbon directly connected to 1 carbon, primary, which will undergo reaction least tertiary. So your answer is second one. Okay, simple one, same theory but different level of question, different type. Next one. Arrange the following compound in the order of their SN2 mechanism. Again the same question. What is the reason? What is the order? Primary greater than, secondary greater than, tertiary. Dear student, first compound, let me rewrite it. CH3, CH2 thrice. CH2 thrice means 3 CH2 group, 1 more CH2 with the Br. Second one is CH3, CH3, CH2, CH2, Br. Option third one, CH3, CH2, CH3, CH2, Br. Option fourth one, CH3, 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 CH2, Br. Alright. Here all. Which will undergo, what is the question? Arrange the following compound in the order of their reactivity of SN2 mechanism. Okay, let's take it. Here bromine connected carbon is directly connected to 1 carbon, primary. Here bromine connected carbon directly connected to 1 carbon, primary. Here bromine connected carbon only 1 carbon, primary. Bromine connected carbon directly connected to 1 carbon, primary. Oh my god. All are primary, right? If all are primary, what we have to do? We cannot use this one. We cannot use this method. So we can check it. What is SN2 mechanism? Nucleophile is attacking to the halogen connected carbon to the opposite direction. So where is the nucleophile is coming? Nucleophile is coming to this carbon atom. So this halogen will leave. Here nucleophile is attacking to this carbon atom. Halogen will leave. Here nucleophile is trying to attack on this carbon atom, halogen can leave. Here nucleophile is coming to attack on this carbon, halogen is leaving. This is what happened. Which attack is easier? Where the attack is easier? I think in the first compound, because in the first compound nucleophile is very free to attack on carbon, there is no branching or something. So first one greater. Okay, first one greater. Then after that, second one or third one. Second one you can see there is a methyl group here. Third one there is a methyl group here. So where is the attack is easier? By the diagram it is very easy to understand. Second one, it is easy because the methyl group is little far away from the halogen. Option 3, methyl group is come closer to the halogen, so less reactive. But in option D, there are two bulky group. Reaction will be very steric hindrance. So fourth one. So 1, 2, 3, 4. That should be the correct answer. Option A is the correct answer. Clear? Okay. Then which of the following haloalkane is most reactive? They didn't say whether it is SN1 or SN2. Let's go. 1 chloropropane. 1 chloropropane. B is 1 bromopropane. And C is 2 chloropropane. And D is 2 bromopropane. Which is more reactive, dear student? They didn't specify anything whether it is SN1 or SN2. Which is a most reactive one? Let us check it. You know, this is primary, this is primary, this is a secondary, this is also secondary. When you consider primary, secondary, tertiary, if they didn't specify anything, mostly they will prefer SN1 mechanism. SN1 mechanism. SN1 mechanism order is tertiary greater than secondary greater than primary. So here primary is there, secondary is there, so secondary is greater. Among options C and D, which can undergo reaction faster, which is the best leading group? Chlorine or bromine? Bromine. Down the group, reactivity increases. So bromine containing compound secondary one undergo reaction fast. 2 bromopropane. Here they didn't specify. Don't worry. In the most of the question they will specify whether SN1 or SN2. Okay. Now, which of the following reaction does not take place? Which of the following reaction does not take place? Let's see. First one is given ethyl bromide treating with the KNO2. Yeah, when we treat a haloalkane with the potassium nitrate, we will get the ONO. Yeah, nitrite. Correct. When a haloalkane treated with the AgNO2, you will get NO2. Yeah, correct one. When a haloalkane treated with the AgCN, we will get isocyanide. Yes, correct one. We studied. When a haloalkane treated with the KCN, then also isocyanide. You know, when you treated with the KCN, we should get cyanide. CN, not NC. So that is the incorrect one, right? Option D is the incorrect. Consider the following bromide. The first bromide is given. What is Me group represent? Methyl group, CH3. So first one, let me write it. CH3, CH2, 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 Br. What is second one? CH2, double bond, CX, single bond, CH, Br, single bond, CH3. What is the last one? CH3, single bond, CH2, single bond, CH, Br, single bond, CH3. Okay. Let me take the compound as number 1, number 2, and number 3. Question is, what is the correct order of SN1 reactivity? I think the first compound is primary, second compound is secondary, third compound is secondary. So there is no usefulness for the order tertiary greater than secondary. Dear student, SN1 mechanism, you know, the first step is formation of carbocation. So it depends on stability of carbocation. Let me give you the entire stability of carbocation. Stability of carbocation is in the order. All of you keep in mind. Okay, let me give you here. Stability of carbocation is in the order tertiary greater than benzyl carbocation. Benzyl carbocation greater than allyl carbocation greater than secondary greater than primary greater than methyl carbocation greater than vinyl. Vinyl is the least one. Vinyl is the least stable carbocation. Okay, tertiary greater, then benzyl, then allyl, then secondary, primary, then methyl, then vinyl. Okay, let me give you the small structure here. What is meant by tertiary? Tertiary means 1 carbon connected to 3 carbon. This is tertiary. What is benzyl group? This one, right? Benzyl carbocation. What is allyl group? CH2 double bond, CH single bond, CH2 plus allyl group. What is secondary? one carbon connected to 2 CH3. Then what is primary? One CH carbon connected to only one S. And what is CH3 plus? What is vinyl group? CH2 double bond CH plus. This is the stability of maximum carbocation. Let us take it here all. First question I am going to. What is the first step in SN1 mechanism? Elimination of halogen, formation of carbocation. Okay, let me eliminate halogen. This is the carbocation. This is bromine, eliminate carbocation. Bromine, eliminate carbocation. Identify which carbocation is the first one. The first carbocation is a primary carbocation. Why? The carbocation directly connected to only one carbon. It's a primary. What about second? If you eliminate bromine, the CH carbon, it is actually a secondary one. More than that, it is allyl. Why? The CH carbon connected to CH another carbon, double bond CH2. Check it. This is allyl group. So what is this? It is allyl carbocation. Allyl carbocation. Alright, fine. Okay, what about the last one? This is bromine carbons. This CH carbon directly connected to two carbon. This is secondary. So tell me, dear student, which carbocation is more stable compared to primary, secondary, allyl? Allyl is more stable. Therefore, we can say the order. Second one is greater than, then secondary, third one, and then first one. This is the order. Means B, C, A. Yeah, option B is the correct one. B, C, A. Okay. So if the order for SN1 mechanism, tertiary, secondary, primary is not possible in the question to answer, you can go through stability of carbocation. Right. Next one. Which of the following statement regarding SN1 reaction by haloalkane is not correct? SN1 mechanism, let us take it. What is the first one? The added nucleophile plays no kinetic role in SN1 reaction. First one. SN1 reaction involved the inversion of configuration of the optically active. Inversion of configuration is happening in SN1 mechanism? No, right? Retention of configuration. The SN1 reaction on the chiral starting material end up with a racemization. I told you SN1 mechanism, racemic mixture, you will get it equal amount of dextro and levo. The more stable the carbocation intermediate, faster the SN1. Yeah, SN1 mechanism for the dependence of stability of carbocation, or the carbocation stable form, it will react faster. So, which is the answer? Option B. Inversion of configuration. No, in SN1 mechanism, there is a retention of configuration is happening. Which of the following chlorohydrocarbon readily undergo solvolysis? What is the meaning of solvolysis? It can dissolve in a solvent or not. It can dissolve in a solvent or not, like water, etc. This is what again they are checking. Whether which will undergo SN1 reaction faster. So different types, okay. Solvolysis means ability of the substance to dissolve in water or in solvent. So which is undergo faster mean which is highly stable towards SN1 mechanism. SN1 mechanism favor the formation of carbocation, right? Let me remove each chlorine from the system. I am removing the chlorine, so this is the carbocation. I am removing the chlorine, this is the carbocation. I am removing this chlorine, this is the carbocation. Removing this chlorine, this is the carbocation. What carbocation is the first one? First one is a vinyl carbocation. First one is a vinyl carbocation. We discussed vinyl carbocation is very least stable, so it will not undergo reaction faster. What is this? What is this? If option B, if the chlorine eliminated, you are getting phenyl carbocation. Phenyl, it is also very least stable. Okay, vinyl and phenyl are very least stable. What about option C, dear student? This is benzyl. This is benzyl. Benzyl carbocation. You know, benzyl carbocation is highly stable. See the record. See, benzyl carbocation. Benzyl carbocation is little greater stability, so that he will undergo reaction faster. What is the other one? What is this one? This carbocation directly connected to one carbon. It is a primary one. Benzyl is the most stable carbocation. It will undergo SN1 reaction faster. Okay. Next one, dear all, which of the following is the most reactive towards nucleophilic substitution reaction? They didn't specify SN1 or SN2, but we will get a clue. Option A. Option A given chlorine with the CH2, CH double bond, CH2. Option B, CH2 double bond, CH single bond, chlorine. Option C, CH3, CH double bond, CH single bond, chlorine. Option D, C6H5, Cl. See, while looking the compound, you cannot see any kind of tertiary or secondary group. Mostly all are primary, except the last one. All are mostly primary, right? So how you can identify which is highly reactive, undergo nucleophilic substitution? You please eliminate the halogen first. If I eliminated chlorine, I will get this carbocation. Chlorine, this carbocation. If I eliminate this chlorine, this carbocation. If I eliminate chlorine, this carbocation. Which carbocation is the first one? Can you identify? The first compound, when they eliminated chlorine, you are getting a allyl carbocation. This is a allyl carbocation. This is a vinyl carbocation. This is just a primary carbocation. This is a phenyl carbocation. Which carbocation is more stable? Allyl. So he will undergo reaction faster. Okay. Next one. SN1 reaction is faster in. What is the reactivity order of SN1? Tertiary greater than, secondary greater than, primary. First question you can see bromine connected carbon, only one carbon, primary. Chlorine connected carbon directly connected to 2 carbon, secondary. Chlorine connected carbon directly connected to 3 carbon, tertiary. Chlorine connected carbon directly connected to 2 carbon, secondary. Who will undergo the reaction faster? Tertiary. Option C is the correct answer. Even you can check the stability of carbocation also. Tertiary will be the most stable. Which of the following alkane halide undergo or hydrolyzed by SN1 reaction faster? Come on, which one? Now you get so much idea about SN1 and SN2, right? Which will undergo SN1 reaction faster? First one is primary, second one is primary, third one is primary, fourth one is tertiary. Tertiary will undergo reaction faster. Correct? Option D is the one. Which of the following will give enantiomer pair on reaction with the water due to the presence of asymmetric carbon? What is meant by asymmetric carbon? A chiral carbon. Where you can identify a chiral carbon? Just 1 minute, all of you look into the table. Identify where is chiral carbon. Come on. Where is a chiral carbon? Where is a chiral carbon? Come on. Where is a chiral carbon? Yes, I think your answer is option C, right? Option C, because if you look into the central carbon atom, it is directly connected to one hydrogen, one ethyl, one methyl, one iodine. All are different group, therefore it is chiral or asymmetric carbon. All should be different. In the following pair of halogen compound which undergo SN1 reaction faster, you can see the first pair. 2 compounds are given. What is this? The first compound here? This is the first compound. Chlorine connected carbon directly connected to 3 carbon. It is tertiary. Here chlorine connected carbon directly connected to 2 carbon. Secondary. SN1 reaction faster in tertiary or secondary? Tertiary. So first one will undergo reaction faster. In the second pair, chlorine connected carbon directly connected to 2 carbon. Secondary. Here chlorine connected carbon directly connected to 1 carbon, primary. Among primary and secondary, which will? Secondary will undergo. Correct? So the first compound, the first one will undergo reaction stronger. Second reaction, second pair, first one will undergo reaction. So 1, 2, what you can identify? Option B. Correct? Option B will undergo reaction faster. Next one, all of you. Which of the following haloalkane react with the aqueous KOH most easily? Again, aqueous medium mean no doubt you have to follow SN1 mechanism. Let us check it. Option A, 1-bromobutane. 1-bromobutane. Option B, 2-bromobutane. 2-bromobutane. Option C, 2-bromo-2-methyl-propane. I think your answer is ready. See dear student, this is primary, right? This is primary haloalkane. This is a secondary haloalkane. This is a tertiary haloalkane. SN1 reaction faster in tertiary. Okay, very expected question related to SN1 and SN2 mechanism. Next one. Which alkane halide exhibit complete racemization? Racemization or racemic mixture you are getting only in SN1 mechanism. Again the question, which will undergo SN1 reaction faster? Option A, let me rewrite, CH3, CH, CH3, Cl. Option B, CH3, CH2, CH2, Cl. Option C, CH3, CH2, Cl. And option D, C6H5, CH2, Cl. All of you eliminate chlorine. If you eliminate chlorine, this is the carbocation, this is the carbocation, this is the carbocation, this is the carbocation. Which carbocation is the first one? The carbocation directly connected to 2 carbon, secondary. Here carbocation directly connected to only 1 carbon, primary. Hello, carbocation connected to 1 carbon, primary. Here carbocation, which carbocation is this? Benzyl. Benzyl carbocation. Which carbocation as per the stability order which I given, which is more stable? Benzyl carbocation is more stable. So he is ready to undergo reaction faster. Option D is the one. Okay. Now, what is the order of reactivity of various alkyl halide nucleophilic substitution? We discussed many times. They given alkyl with the fluorine, alkyl with the chlorine, alkyl with the bromine, and alkyl with the iodine. Who is most reactive here? Iodine, right? Because the fluorine is most electronegative element, the bond will be very stronger one. Down the group, iodine is bigger in size, bond is weaker one. So this bond is very weakest. If the bond is weakest, it can break it so easily, it can undergo reaction faster. So down the group, reactivity increases. So Ri, Rbr, Rcl, Rf. Option A is the correct one. Next one dear all, 2-bromo-3,3-dimethyl-butane. What is the compound? 2-bromo-3,3-dimethyl-butane. Okay, this is the compound. It is reacting with which one? Aqueous KOH. Aqueous KOH means what? Nucleophilic substitution, right? Bromine eliminate, OH substitute. OH substitute. But here there is a very important thing. There is a chance to make mistake. If you simply substitute OH and Br, it will be wrong. Okay, it will be wrong. Why? First you remove bromine. After removing bromine, what is the carbocation you are getting? This carbocation. Which carbocation is this? Primary, secondary or tertiary? Secondary. Why? Because the carbocation directly connected to 2 carbon. Correct? This is a secondary carbocation. Fine. Now, you know what is the stability of carbocation actually? Tertiary greater than, secondary greater than primary. You know, at present we have secondary. You please check it whether we can make, there is a chance to make it as tertiary or not. Yes, there is a chance. How? You look at the nearby carbon. If you look into this carbon atom, it having 3 methyl group. If you transfer one of the methyl group into this carbon, so the positive charge will be on the C carbon. What you will get? CH3, CH, the bromine already removed, CH, then CH3, this removed CH3, then C, CH3, CH3. Now the new positive charge is here. What I did is clear. From the nearby carbon, one of the CH3 I transfer. Actually, you have to preference to give for hydrogen shift. On this carbon, if it carrying a hydrogen atom, you try to shift the hydrogen first, because hydrogen is the smaller element, movement is easy. That is called hydrogen shift, hydride shift. If hydrogen is not there, if you want to make it as tertiary, you can take methyl group. Okay. So you are now this carbocation directly connected to 3 carbon, therefore it is tertiary. Okay, fine. After making a more stable carbocation, then you try to add your OH group. Okay, what is the nucleophile? OH group. So it will come to this side. CH, CH3, CCH3, CH3, OH. This is your final product. What is the name? Select the longest chain. This is the longest chain. CH3, CH3, OH. OH is the major group. So number 1, 2, 3, 4. Second position and third position 2 methyl groups. So 2,3-dimethyl, 2,3-dimethyl, total 4 carbon. So butane 2O. This is the 2,3-dimethyl butane 2O. Right? Option C is the correct one. So careful all of you. In this kind of carbocation forming reaction, if you are getting a secondary, immediately please don't add the nucleophile. Please check it whether there is a chance to make it as a tertiary or not. How to identify? Look at the nearby carbon. If there is a carbon with a hydrogen atom, hydrogen you can shift it if you are getting a tertiary. If hydrogen is not there, you can shift a methyl group. Okay, that's it. Alright. So almost most of the question we discussed for haloalkane chapter. Some more previous and most expecting question we have to discuss. So I will come with some more question in the part 2 for the same chapter, haloalkanes and haloarenes. So all of you prepare well. Okay, we'll meet you in the part 2 for the same chapter, haloalkanes and haloarenes. Okay.